We continue on with our next panel on AI quests. This is a really exciting topic. I'm particularly enthusiastic about the way in which this group is going to be able to share with us how we are translating complex research into age-appropriate lesson plans. And so we have a terrific panel here with colleagues from Google Research and from the Accelerator for Learning at Stanford. So we have Alon Harris, who is a senior program manager at Google Research and is the lead for this particular initiative. Victor Lee, who is an associate professor at the Graduate School of Education and a faculty lead for AI in Education at the Accelerator for Learning. And then our moderator will be Ronit Levavi-Murad, who is a senior director at Google Research, who works across a number of domains, but has a particular passion for education, and is a sponsor of a number of initiatives at Google Research, including the one that we're going to talk about today. So let's welcome our next panel to the stage.
Welcome to AI Quests. My name is Professor Sky, an AI expert and your mentor throughout this learning experience. We've been waiting for someone like you. You're about to begin a journey through our world. As you travel, you'll meet different inhabitants and learn about the challenges in their communities. Your mission is to help them by applying powerful AI responsibly to their problems. Each quest will teach you about a real-life AI research project that's making an impact back on Earth. The AI technology you'll experience is amazing, but it's not magic. Success depends on the decisions you make. You'll need to collect good data, train your AI to make smart choices, and test it to make sure it's reliable. The universe is counting on you. Are you ready?
It's good, yeah.
Okay.
Hi, everyone. Yeah. And welcome to our panel, AI Quests, when learning sciences meet product design toward AI literacy. If there's one word that I'd like to highlight today is the word meet. We are here because the three of us are convinced that a cross-disciplinary approach is not just helpful, it's essential. It's wonderful to be here today, and I want to thank Victor and Isabel. Are you here, Isabel?
There's Isabel.
Hi. Thank you for the opportunity to showcase a project that is truly near and dear to our hearts, AI Quests. This initiative is an outcome of an incredible collaboration between Google Research and the Stanford Accelerator for Learning. I'm joined today by the architects of this synergy, Victor Lee and Alon Harris. They represent today their respective teams. And I think that Joba and Kristen and Chris are all here today. And we have Liat on live stream. Thank you all for your critical role in bringing this vision to life. Before we dive into the specifics of AI Quests, I'd like to zoom out a little bit and address a broader landscape of AI literacy and readiness. Like many of you here today, this panel shares a deep commitment to preparing the next generation for an AI-driven future, or perhaps I should say, it's here. It's already here, right? This future has already arrived. We are seeing a widening gap between the velocity of AI development, tech development, and the depth of human understanding. We've talked about it along the day. The metrics are telling. While 72% of students are routinely using AI on their day-to-day, only 28% can accurately describe how a large language model actually predicts text. Victor, your first question is to you. To bridge this gap, You've been advocating for a shift from simply teaching AI usage to fostering epistemic vigilance. That's the term you use. You believe students must learn to navigate machine reasoning with true confidence. Looking at that transition from surface-level prompting to independent critical thinking, what is the roadmap for achieving it?
Thanks for the question, Ronit. Thanks, everybody, for joining us today, and thank you for this partnership. It's just really been a delight to work together on this. One of the things that we really need to think about is what we're aiming for with AI literacy. So I think the big mistake, and we saw this play out early on, was everyone said, oh my goodness, prompt engineering is the career of the future. We need to focus on everybody learning how to prompt. And so that in some way became synonymous with becoming AI literate. And what I would say is that's really, barely the surface of anything in there. When we think about becoming AI literate, we do want to think about, how do you use AI, but that interface and that experience is going to change. We need to think about what's the durable interaction and positioning that individual or student has with the technology as it continually evolves. To some extent, we need to understand a little bit about the mechanisms that it works, that it's not magic underneath there, that it's not a person hiding in there, although I think there was some reports about like Waymo cars maybe secretly being controlled by a person in the Philippines. But for most of the AIs, not. And so I think really that's orienting towards a critical mindset and one that emphasizes human agency, to think like, what is the role that humans had in creating this technology? What are the responsible ways to use and engage with that? And with that technology, it also means, look, I know chatbots are definitely having their moment, but AI is so many more things than that. And so helping people to see, like, what is that? How did this notion of chatbots extend from these other principles of machine learning and the use of data to build predictions or to classify or other things of that ilk? And so really, it's about directing towards a way of thinking about and viewing AI that involves humans, strengths and shortcomings and ways that we work on perfecting that, and positioning students and our educators as agents in this, to really have a sense of agency in like how we use AI, how we create AI, how we evaluate AI, and that epistemic vigilance is really going to be about maintaining that real thought about what we bring to the table as humans, what we need to really be thoughtful and careful about.
Thank you, Victor. I couldn't agree more. And speaking of this theme of human agency, moving from passive users to active critical thinkers, I think that this is the perfect segue into how everything started with AI Quest. So, Alon.
Thank you. Yeah, I'm happy to tell a little story here. First of all, Victor and I have been working for over a year and a half together, but this is the first time I've ever met him in the flesh. So thank you, Isabel. He's real. He's in 3D here, and so it's just that was already worth the travel just to come and see Victor. The story of AI Quest begins not far away from here at the headquarters of Google in Mountain View. And about a year and a half ago, we were having a brainstorm. Google Research has been doing volunteer work to bridge tech to teens for many, many years. But AI literacy is kind of there's no playbook, right? And we were asking ourselves, recognizing what Victor said, that there was the curricula out there. We did some of our market research, and we saw there's a lot of emphasis on technical skills, on coding, speaking about the technology, but basically outside of any human-related context, we said, how can we address this gap in the AI literacy space, but authentically as a research organization? And so we looked to our own research for the answer. So Google Research is investing in societal impact through AI. We have teams that when they go to work in the morning, what they're thinking of are these grand challenges of humanity, whether they're related to climate and sustainability, or to health, or to science. They're asking questions like, how can we give society early warning before a flood hits? How can we provide early diagnosis for diseases to populations in developing markets that just don't have a doctor nearby in a local clinic? And in terms of science, they're thinking of the human brain, and how can we actually map that brain, knowing that it will take thousands of years if we use the current state-of-the-art methods, and thinking of how AI can help. And so we thought, wouldn't it be interesting if we could provide students the opportunity to step into the shoes of a human researcher and go on a journey to try and answer these questions the same way we do, but in a gamified, immersive experience. And this is the birth of AI Quests. What you see here on the screen are the 3 quests we're currently working on. The first 2 have been launched, and the third will be arriving in the summer. These are open, free, instructor-led experiences, and they're all, we'll go into this in a minute, but they're occurring in a fantastical world, and students there have to explore. We're not going to explain up front. We're going to let them loose. They're going to have to try and figure out how to solve these grand challenges. And that's, that was the beginning of the idea. But the most important thing, I think, in this concept is early on we recognized that we're a tech company. We need experts in learning science, partners who will co-design this with us, that will bring their understanding of the target audience. It's been a long time since I was in middle school. We need people who engage regularly with these audiences, know their, their behaviors and attitudes towards the world in tech. And so it's just been a privilege working with the Accelerator for Learning here at Stanford. And everything you're going to see here today is a result of that fruitful collaboration.
Alon, I'm still super excited about this vision. And I'd love to get into the mechanics a little bit. So, and I'm sure everyone here is curious to learn more about, everything, the experience that the learner is going through. So please, if you can share a little bit more.
Can I double check that everyone's curious about what the learning journey is in AI Quest? Can
Please
I see
say yes.
a bit of energy here after lunch? I know it's
Okay.
it's a tough hour after lunch, but biology is a challenge. I want to highlight, the first thing is, before we go into the gamified experience, the teacher is at the heart of our concept. We have outstanding teacher guides created by Stanford to guide teachers for the setup, the before and the after of this online gamified experience, trying to basically emphasize that educators are the ones who are going to socialize, facilitate, have these deep conversations with the students, and what we're providing with the gamified experience is the stimuli. And what you will see here is the standard kind of cycle or journey we send students on. And it begins with understanding the problem they're trying to solve. We spoke in the panels earlier today about human-centered AI. So it begins with understanding who are we solving for and what are we trying to create before we go into the techie stuff. And here you see the quest for flood forecasting. Each task is mimicking the life cycle of a research effort. You have to go and search for data. Data doesn't just readily jump on command, and it's not available necessarily. Students are going to have to distinguish between relevant and irrelevant data. And so we purposely make it hard. There's 12 data sources they need to, like in a scavenger hunt, find in the forest. They need to clean the data. Students don't know that there is a process of qualifying your data for research. You have to clean it. They love this step. And then they go through a training and testing cycle where they understand that if they made bad choices upstream, they're going to get a really suboptimal AI model downstream. And so built into the quest is a loop where students may have to retrace their steps and change their decisions and make better decisions to see if the model performs better for the community they're trying to serve. And at the very end, they deploy their tool to the community, see it in action, because an AI model in a lab is one thing, but if we're going to do societal impact, really make a change, you have to see it in the real world. And just for dessert, at the end, they get to meet the real researchers. So we kind of unveil to students that this isn't just a nice animated experience. This is something that teams, people, experts are devoting their lives to. And here they'll meet Gray and Tal, who will tell them about the work they do to create flood forecasting for 2 billion people around the world, that we can today, with AI, provide up to 7 days early warning before a riverine flood occurs. So this is kind of the general gist of it.
That's fantastic. Thank you, Alon. Let's talk about pedagogy for a moment, and I can see my colleague Miriam here, actually. I just want to, hi, my love. I just want to, I'd love to hear your thoughts maybe afterwards, but I'm going to talk a bit about LearnLM and our experience with LearnLM, because when our team at Google, when we built LearnLM at the time, our family of models specifically tuned for learning and education, our foundational principle was to ground everything in a rigorous learning sciences, right? And it's clear to everyone here that pedagogy is not just an add-on or something like that, a feature. Everything we build for learning and education must be co-designed with experts, with teachers, with learners, with parents, right? And beyond that. So Victor, related to that, I've heard you talk about the magic box myth, where students assume AI just knows the answers. For AI Quest, we didn't just want to build a game. We wanted to bake in that pedagogical foundation. Could you explain how AI Quest actually empowers a 12-year-old to demystify that box and start thinking like a researcher?
Yes, for sure. I mean, I think for those of you in learning sciences and instructional design worlds, you're familiar, this needs to be sort of the front and center commitment in terms of how do you even identify and centralize what learning goals you're pursuing in there. And so using techniques that are familiar with in a backwards design paradigm, you know, naming and centering the enduring understanding that we really care about. In this case being humans can initiate and design AI applications that can address some of humanity's biggest unsolved challenges, and latent in that is the ethical responsibility that is associated. And what that does is it really shifts the focus away from what's the mechanism underneath it, but rather what is this like within the actual types of real questions and problems that we try to address. And then, you know, as a broad statement for the approach is you then want to think about what we have established from, you know, recent learning sciences research about scaffolding, digital scaffolding, and the ways in which we can best support learners, both for engagement and for new knowledge and new participation in practices. Like we, for instance, have very thoughtfully, strategically used the various digital characters, various pedagogical agents that are there to help make clear like what is the consequence of the actions that are in here, where is their subject matter expertise that is necessary.
Oh, one moment. Oh. So yeah, we've got Luna here. She's competing with Victor. Luna is the character.
That's one of the pedagogical agents. So she will illustrate that for us. But also what I'd say is in you know the recent decades of learning sciences research, it's situating this all in context and thinking about where the scaffolds fit within that context. A lot of what we learn is fundamentally all we learn is within the context, with actual purpose, with tools, with norms, with actual concerns and consequences in mind. And so this, I think, is a really important and unique offering in the AI literacy space to give that full experience, not just say, this is what a neural network looks like, but rather this is how this all fits within this arc. How do you make those decisions? What tools do you draw from? How do you involve and work with the other people, or in this case, agents in that? And so that immersion, that way of bringing that to life to really acknowledge the social, situated and distributed nature of human learning and doing is key. And I think Luna will help illustrate
Luna will help us, yes.
Oh no! We're in so much trouble. Hi, I'm Luna, the manager of the market stalls here at Market Marshes. Our lives revolve around the Sasa River. But as you can see, the river can flood our market without warning. We didn't even have enough time to take the stalls down. We've been trying to predict flooding, but this weather forecast isn't reliable enough. We've heard that AI can help to predict extreme weather events, like floods. With accurate early warning, we can protect our market and avoid all this mess. So can you do it?
So, Victor, I've got a few examples here. Maybe we can talk to the cleaning data.
Sure.
Yeah, sure.
So right there you saw Luna, who's setting the context and saying, why does this matter? We also thought a lot about how do we represent things, such as like what would prediction of weather look like in a way that's accessible, but still has that probability-based nature to it in there. And that's really been sort of the driving orientation around a lot of the tasks and experiences. So for example, cleaning data and about how much involvement, because in reality, cleaning data takes a lot of time and a lot of energy, but getting students to think about what would I look for, what would seem anomalous, and build upon my understanding or parsing of this particular context, and having situations where the students can fail and need to redo that. We build in these self-explanation mechanisms afterwards, so that way when they pass on that cleaning data task to one of the other agents in the game, they have to articulate what it is that you need to look for and do in that process. We have, for instance, this market stalls placement task, working with the kinds of color-coded data representations to show where there's high and low risk for flooding, and to also tie things back into what was driving the story in the first place. So that way, what would you do if you had advance warning and you really do need to keep the markets operating, regardless of the conditions, and how do we do this safely and responsibly? And so a lot of this is really thinking about how can we keep that context alive, keep the content accessible, but still accurate, both scientifically and to what actually happens in the journey, and to build in productive failure loops, because trying and retrying and getting the feedback is fundamentally important to that learning process. As you probably heard, there's a lot of things that we build in the pedagogical approach, and this again is really very much built from our work in the learning sciences, feedback and productive failure. And as you can see, you can really have incorrect data, or you can actually build a model that just doesn't meet accuracy criteria, and you could even build higher than that. Our pedagogical agents, and thinking about this notion of the specific type of a teachable agent, so leveraging that ability that a lot of the strong research that actually come out of Stanford on this, about how teaching a virtual entity to make some of the decisions that you would make is a really good externalization, a good sort of consolidation and way to see the consequences, implications. Self-explanation mechanisms, which is a long-standing long-standing mechanism in learning sciences that we know that expert comprehension tends to draw upon, and situating this with real tasks such as having to consult multiple experts who may not always agree on what label to assign, and try to maintain that authenticity, as is illustrated in this particular case of labeling, expert labeling of data. So we really think about that. We think about, even with, for the next slide, the teacher support materials, because over the past decades, all this work in learning sciences, all this design work in classrooms has made starkly obvious the importance of working in tandem with a teacher, supporting their adaptation processes, creating lots of connection points and malleability with the materials, but also helping them to feel empowered to teach and engage students on this topic that's not as familiar to them. And so thinking a lot about what a lot of the recent research has said about teacher learning, teacher practice, curricular materials-based support.
Thank you, Victor, and thank you, Alon. Now I actually have a question for both of you. But before that, I must say that this partnership between Google Research and the Stanford Accelerator for Learning really represents a rare intersection of academic rigor, product development, experimentation, and real-world impact. Now, looking back at a year of co-design, I'd like to get into the weeds a little bit and talk about the intense reality of co-design. Can you share a moment where you had to stop, put your heads together, and decipher truly tricky design challenge?
It's a tricky one.
Okay.
First of all, I just want to highlight that Victor and I, we did a demo here at lunch, and we were saying to each other, you come, you have a beautiful presentation. It looks like it was all predestined to just be such a smooth journey. And I want to say the biggest surprise is that Victor and I are still speaking to each other, okay? Because it's been a creative journey. It's an iterative journey. And then you take it to the students, and test it with them, and then you learn that some of your assumptions are off, and you have to iterate. So I think, Ronit, this has been a journey of co-creation, which means negotiation. It means finding common ground and finding a way of balancing between not just our part here, but also the creative agencies that we worked with to bring this art to life, and the students and the teachers that we tested this with. But one example, Victor, I thought it would be interesting is we spent hours trying to understand how to explain training and testing, but not to dumb it down and make it too simple, but not to make it over-technical and alienate the students. And that middle ground, that sweet spot, is really hard to find. And so we have like 1,000 versions of what you're seeing on the screen, and I'm sure one of the things with animation is you know that you can erase and do it again. So we also had to be disciplined when to say stop, to say, okay, let's go with this, because we could continue easily iterating forever. And I really loved the low match, high match solution we found. We wanted to express that in testing, we're comparing the ground truth from historical data with what the model shows. And this is a very complicated concept of historical data and accuracy, etc. And so we had this beautiful illustration here that shows a high or low match between these two visuals. So it's almost like a visual expression of something more complicated. Victor, you want to?
Yeah, I mean, I think related to that is how do you convey that the AI is making a prediction against something that we have as a more trusted and accurate source of information. So that's been a recurring theme, but also, as students go through this, for them to understand where was the AI in this and what does the AI actually do? How did it get made and how do we represent that without them thinking, oh, you really have to know all the math behind it to get there. And so there's been a lot of really careful things, even going to the point where when image-based data are used to train the model, we have a whole segue about how it needs to convert to things like numbers, so that way it becomes a form that the AI can use to get away from sort of a growing misconception that AI sees and perceives as humans see and perceive. And so it's just those sorts of details about how can we maintain that accuracy and fidelity, but in a way that doesn't get bogged down in the details and still maintains a lot of that.
One thing I learned from you, Victor, early on, you told us teenagers don't understand what data is. It's an ethereal...
It's a phone plan.
What is data, right? And let alone other terms like model that we spent time on, etc. And so we tried to represent data without showing it. We didn't want to overwhelm them with tables with numbers. So at the beginning we had this idea of maybe using tokens like in a game, but then we transitioned to something that was kind of a metaphor, which was these SD cards, and then students they'll, oh, okay, it's storage, it's something you store information on, and I think that was a really cool kind of solution we found. And I bring these, I went down memory lane, I went 500 versions ago to the black and white versions you see here, which is where we start all the journey. And I think with this quest, which is about diagnosing eye disease early on, we had a hard time with the story. The real story is about diabetic retinopathy. The real story is about losing your eyesight to the brink of blindness. And now that's a really stark kind of starting point for something gamified. And we tried to find a way to kind of decouple this from any medical background. And we came up with the idea of a community on this planet that has an eye disease due to UV. And this was kind of, I think, a creative solution, which is something, okay, kids in general can relate to the sun, to UV, they have some knowledge of that it's not healthy. And we found that way of addressing this and kind of bypassing the need to go through anything that might trigger anything negative.
For example, I know there's consultation sessions with Googlers who are blind and low vision themselves, or work on the accessibility teams to consult and discuss. And also thinking about, well, how do we get to this problem of data diversity in this fictional world? And within that context, We wanted to, knowing that there has been and continues to be a tendency to think about like a biological essentialism, to move away from something that's like a biological trait, like the eye color or the shape of their eyes, and thinking about how can we more accurately represent what would be the science, but also ways that speak to the importance of the diversity here, and in this case, diversity of UV exposure at different regions in the planet, which created all these interesting and fun game mechanisms and unveiled all these new lands.
Amazing. We are almost at time. We actually at time. But I want to say, before we say goodbye, that the feedback on AI Quest has been phenomenal. Now, can you give me some of this feedback? Can you share what you hear from the classroom? A little bit, just a little bit for everyone to hear. Yeah.
I mean, I think that it's been fun and engaging and at a pace that doesn't feel like it drags and still has enough of the game mechanics that keeps things moving forward. I've tested this with my teenage daughter and friends, and they're sort of like roll their eyes and like go through it, and I say, so what was the big point? And in their words, it was precisely where we wanted that enduring understanding to land in there, and that was just a big hit that message had come across, even though it's very subtly embedded within all of that. So I think that was a really encouraging thing, and just people to ask about it. And I've had compliments from strangers, which is really nice.
Amazing. Alon.
Yeah, we sent 600 volunteers from Google to schools in their community last December for Computer Science Education Week here in the US. And this was, for some of them, going back to the school they studied in and coming with this experience for the first time. And the feedback was, students felt that the story enabled them to go like, now I see, this is not just chatbots, right? There are problems still that we haven't solved. This is a means, it's not an end within itself. And that was just fantastic. And I just want to highlight the third quest, which will be about mapping the human brain. It's in the works. We're losing sleep on it, but that's part of the labor of love, right? Because we really want it to be, a great focus on science, on the rigor it takes, and how AI can accelerate taking a lab, in this case, that's trying to understand memory and help accelerate the discovery of the inner workings of memory in the brain. And I think students are going to love this. Yeah.
Great. So to sum up, it sounds like a lovely 2026 is underway. We are launching the third quest, and we have a bold goal of reaching to 2 million students until end of year. So that's incredible. We invite everyone here, policymakers, educators, parents, funders, to join us.
Kids. We've got students here.
Your kids, your students. Let's co-design a future where technology truly serves pedagogy. That's the goal. Victor, Alon, it's been a pleasure sharing the stage with you.
Thank you.
And thank you, everyone.
Thank you. Thank you, Ronit.